thought we'd take a look at finding some areas with some double integrals. I'm actually going to show this problem in the method we learn in Calculus 1. And then I'm going to show it with a double integral to show you how it's a little bit easier. Let's first of all get an idea as to what this area is. Now, when I first looked at this problem, it didn't like dawn on me what that shape was. And so if you're like me, you kind of need to see it in its standard form. Then what I try to do is get all the variables on one side. So I took this equation and I squared both sides, which gave me x squared equals 4 minus 4y squared. Then I pulled over the 4y squared and it started to take shape for me. I mean, at this point, I knew it was an ellipse. Then if you want to divide every term by 4, you can easily get the standard form for the ellipse, and you can see that the major axis is horizontal, and it has a length of 2, square root of 4, and the minor axis has a length of is 1. And so if you draw this, and I'm just sketching here, okay, it's 2 in the horizontal from the center, and it's 1 in the vertical from the center here. So your ellipse is elongated horizontally. Okay, then look at the other pieces that are bounding this. It's bounded by y equals 1. So that is this horizontal line here that's bounding the region. And then x equals 2, which is this vertical line. So friends, this is the region. Let me grab a highlighter to highlight it. This is the region we're actually trying to find the area of. It's actually outside of the ellipse. Okay. Now I chose to do this. The first method was with Calculus 1 when I'm doing rectangles. I looked to do my rectangles to be horizontal, which means I'm going to do my integral in terms of y. So my first method to get the area would be to have the right curve minus the left curve. Now the right curve here is a line, so that's just 2 minus the ellipse, which is the square root of 4 minus 4y squared, and that's all dy. Now those rectangles start here at 0 and they end at 1. So that was the way that we've learned to do it before. Now I wanted to do it with a double integral. Now when I do it with a double integral, the first thing I'm going to do, because I'm going to use the same idea running them sideways, I'm going to run my x's from 0 to 2. Okay, so I know that is my outside integral. That is not the first one that I'm going to calculate. It's the second one I'm going to calculate. And I'm going to come inside and I'm going to do my rectangles from the curve square root of 4 minus 4y squared to 1. So that's my rectangle stacking up here. And then that's in terms of dy. And that's how I get my area with the double integral. And here's the key thing is that the two of these should be the same. So I hope that helps. If you have any questions or comments, please leave them below. I would love the opportunity to shed some more light on this. And as always, don't forget to like and subscribe. That way you get a notification every time a new video is posted. Bye for now.